So analytical functions are automatically generate ranking numbers to each row wise or group of rows wise. These are also called as a ranking functions. So how it is going to generate this one? Okay, suppose if you are having some data, so like in the each one. So suppose if you are having the employee number, employee name, salary, so row number. So row number always it will start from the one only, 1, 2, 3, 4, 5, 6, 7 like that. So rank it will assign wherever the same value is there, for that it will assign the same rank. But dense rank and here in the rank it will assign same rank, but in the next rank it will skip it here. Whereas dense rank it will not skip the rank, it will assign, if it is same value it will assign the same rank and it will move on to next rank here. Suppose if you see this employee number is 1 is there, employee name A, salary 1 lakh is there, then row number is 1. When you use the rank it is also 1, dense rank also it is 1. But when you coming to next record here, second record, salary is 90,000, third record also salary is 90,000. Then what it will do? Row number it is assigned to 2 and 3, but here rank it is 2 for the both the records. As a dense rank also 2 is assigned here. Okay, it's coming to fourth record, 80,000, row number is 4, rank it also it is, instead of 3 it is skipping the 3 and it is assigning 4. Why? Because here already it is taking in place of 3 it is 2 it is added here, so that it is skipping the next record, it is adding another record here. Okay, so whereas in the dense rank it is continuing the sequence here. Okay, rank sequence it is continuing here. If it is same value is there, it is assigning the same rank, but it is not skipping the next sequence here. If you see this 1, 2, 2, 3, 4, 5, 6, 6, 7, 8. So that means here if it is third rank it is assigned here, and coming to this record, fifth record 70,000, row number is 5 and rank is 5, dense rank is 4. Same here, salary 60,000, rank is 6, row number is 6, rank also 6, dense rank is 5. So here remaining record 7, 8, it is, if you see in the row number 7, 8 it is there, but it is having the same value. For the same value it is assigning the same rank here. Okay, but dense rank also assigning the same rank, but it is not skipping the next record. So here coming to 40,000 it is, row number is 9 and this is the rank is 9, dense rank is 7, and for the 30,000 row number 10, rank is 10 and dense rank is 8 only. Okay, so what it will do? Row number to assign different rank numbers to the same value. Why will use the row number means to assign the different rank numbers to the same value. If you see this row number, it is assigning in this sequence order only, but it is assigning different. Here 9,000, 90,000 is there, here 50,000 is there. Still it is assigning the 1, 2, 3, 4, 5, 6, 7 in this sequence order only. So how it is analytical function we are going to use this means this is the syntax here. The analytical function name within the brackets and over partition by column name, order by column name, either ascending or descending. Okay, so whatever in this square brackets, this is not mandatory, but over is mandatory here. So over by clause is the mandatory, partition by is optional here. So without using the partition by clause, suppose if you use this salary for the row number, how with this function will works, you can verify. Select ename, salary, row number over order by salary descending from EMP. Okay. So salary in the descending order, it is arranged in the table. So now this 5,000, 3,000, 3,000, 2,975 like that. So coming to the row number also, if you see starting here, row number is there. This is by default when your query, so automatically this 1, 2, 3, 4, 5, 6, 7, 8, these numbers will be automatically generated. First row, first column. If you see before ename, there is a column, it is there. So that is sequence 1 to 14, it is there. Same way when use the row number, that is same, it is displaying here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. So when you separately in the column row number, then it is displaying here. Otherwise, by default, when you use the select query also, by default, this row number will be assigned here. Okay. So if you observe here, it is assigning the row number in this order 1, 2, 3, 4, 5 up to 14. So same query with the partition by class, how will you use this? Select ename, salary, department number, comma, row number over partition by department number, order by salary descending from EMP. So partition by department number means each department number will be separated here. If you see, this is the up to here, this is department number 10. In this, it is assigning the row numbers here 1, 2, 3. Okay. So after that, again within this department number 20, it is assigning the row numbers 1, 2, 3, 4, 5. And in the department number 30, 1, 2, 3, 4, 5, 6, it is assigning. Okay. So row number is here, it is differentiated by using this department number. So partition by department number means within this department number, how many records are there? That count it is there. 1, 2, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5 like that. So without using the partition by department number, simply you are getting this. If you use the department number here also, you can see here. So this is the ascending order of this, descending order of this salary. So now it is, row number is 1 to 14, it is there. Continuous, entire table it is continuous only. When you use the partition by, then it is separating with the department number wise, and within this department number wise 1, 2, 3, 4 like that, it is assigning the row numbers. So next is rank. So why we use the rank? To assign same rank number to the same value, but it is keeping the next sequence rank number in the order. For this also same syntax, analytical function name over partition by column name, order by column name, ascending or descending. So partition by class is not mandatory, that is optional only. So select ename, salary, rank over order by salary descending. So I'm giving enter for this query, or I'm giving here alias name I'm giving from EMP. Then if you see rank, this is the rank alias name I'm giving R here. If you see salary 5,000, 3,000, 3,000, 2,975 like that it is there. So here this is the first rank and this is the second rank. For the both the values 3,000, it is assigned second rank. After the second rank, it is skipping the third rank. Why? Because already it is assigning third rank in place of, sorry, second rank in place of 3 here. So that 1, 2, 2, after that 4, 5, 6, 7, 8, 9. After that 10. Why? Because both the values are same. 1250, 1250 it is same. So that it is assigning the same rank here. So after that again it is skipping the next sequence, that is 11 it is skipping and it is printing 12. Okay, after 13, 14. Same with the partition by department number. Select E-name, salary, department number, rank, over partition by department number, order by salary, descending, and this is the rank from alias name. I am giving rank here. So if you see, difference is again within the department number 1, 2, 3 it is assigned, and department number 20 1, 1, 3, 4, 5 it is assigned. Why it is assigned 1, 1? So the salaries both are same here. So that it is assigned the same rank for these two records, that is 1. So 2 is skipped here now. Okay, within this department number 20, 2 is skipped. And department number 30 here, 1, 2, 3, 4, 4, 6 it is there. So that means these two are duplicate here. That means same value it is present, so that it is assigning the rank for the both the records, and it is skipping the next record 5, and it is assigning next record, that is 6, to the next value, next record. So, but in all the scenarios, rank it won't be useful, so that we have to use the dense rank. Okay. So suppose if you consider the MSET ranks or JEE mains ranks, whatever it may be there. So when you are comparing that ranks, so in that scenario, rank function it is not useful. Why? Because it is skipping the next sequence. In that scenario, we have to use the dense rank. So to assign the same rank number to the same value, but it is not skipping the next sequence number in this order. So dense rank it won't skip the next sequence. For this also same syntax. Analytical function name over partition by column name, order by column name, ascending or descending. So if you see this without the partition by, so how to use this dense rank? Select E-name, salary, dense rank here. This is the analytical function dense rank. I am using dense rank, brackets over order by salary descending, and this I am giving dense rank dr I will give. Okay, d underscore r from EMP. So if you see this, here it is assigning 1 for this first record, 2 for the third and second and third. Why? Because these two are identical. And next, third, fourth, fifth, sixth, and seventh, ninth, here again duplicate is there. So then it is assigning 9, 9 after that 10, 11, 12. Okay, that means in the dense rank it will not, it will assign the same rank to the same value, and it will not skip the next rank. Whereas in the rank it will assign the same rank for the same value, but it will skip the next rank. Same using the partition by clause with this. Select E-name, salary, department number, dense rank over partition by department number, order by salary descending. This is the alias name. Okay, dense rank alias name, so that I will use dr only here also. Okay, within this department number 10, this is the first rank, this is the second, and this is the third rank. Within the department number 20, first, again first it is there, second, third, fourth. Again department number 30, first, second, fourth, again fourth, after that fifth. So suppose I want to find out the nth value, that is some record number I want to provide in the runtime. So select star from, again select e-name, salary, department number, select dense rank over partition by department number, order by salary, descending, and D underscore R I am giving from EMP, where D underscore R equals to ampersand N. So that means suppose if I am giving enter value for N, I am giving 2. So in the each department second rank details it is fetching and displaying here. Suppose in the each department, suppose say 5. So then I'm getting only department number 30. In the department number 10 and 20, there is no fifth record here. Okay. Suppose if you say 3, then it is getting department number 10, 20, 30 also. And within the each department number, this is the third rank. So then you can use this query to select star from, select e-name, salary, department number, dense rank over order by salary, descending order, and you can say dr d underscore r from EMP, where d underscore r less than or equals to 3. So what you are getting with this query, if you see this query, previous classes I told something. So it is inline view.
Subquery.
It is the inline view query. How you are saying this inline view query?
Subquery.
Yeah, subquery, okay. Within the subquery also it is the inline view query. Okay. So this is column alias name we are using. D underscore as this is the column alias name I am using in the where class. So when you are able to use this column alias name in the where class, that is within the inline view only. Okay. So in the each department I am getting this D underscore, that means the dense rank less than 3. That means in the 1, 2, 3. So write a query to display third highest salary employee details from the employee table in each department wise by using the dense rank along with the inline view. So write a query to display third highest salary employee details from EMP table in each department wise by using the dense rank along with the inline view. So inline view means that is we have to use the column alias name. We'll use in the column alias name in where class. In the real time, you have to be arranged in the proper format only. Okay. So this where clause is for outer select statement, and this from for this select statement, and for this from is for this select statement. And these are the columns, and this is the last one is the column alias name here for this query. Okay. So I'm getting the each department third highest salary. Okay, suppose second highest salary, then you can simply put to here. Then second highest salary details I am getting here. Fourth highest salary, that is only within the department number 20 and 30 only it is there. In the department number 10 there is no fourth highest salary. Okay, suppose first highest salary. Okay, so in the previous examples we are taking the entire table, that is either first highest salary, second highest salary, third or fifth, like that entire table I am using the queries I have displayed. But here in the each department, so if you see this, by using the analytical function in the each department, who is having the highest salary? Okay, first highest salary, second highest salary, third highest salary. So using this analytical function, you can easily query the details. So either way you can use it. This one query, and one more is this. Select start from, again select department number, salary, department number, rank over partition by department number, order by salary descending, and this is the rank I am giving from EMP, group by department number, comma salary, and this is for where for outer select statement. You have to be careful while using this subqueries. In the subqueries, you have to check this open and closing brackets also. Okay, anyone is missing, so different output will become, or you will get the end up with this query is not. Suppose if I remove this one, then it is throwing the error, invalid table name. Suppose this side if I remove, then missing right parenthesis. See the difference. One same braces I am removing. So when you use the open braces, then it is giving some other error. When you not using this closing braces, you are giving parenthesis not closed, missing right parenthesis. Okay, so for that you should be careful while using the subqueries. So what are the open and closing brackets are there, that you have to end clearly. Okay. So write a query to display the fourth senior most employee from the job wise. So I want to display fourth senior most employee from each job wise. So for that, what I have to take? I have to consider the hire date column from this table. You can use this. Select start from, select ename, job hire date, dense rank, over partition by job order by hire date, and column alias name or I am giving from EMP, where R is equals to 4. Only 2 persons are there. Okay. So like this, you can use this analytical function to get the details over using the over keyword. So in the analytical function, compulsory over should be there, and partition by is optional. So next we have the lag. So it is used to access previous row data along with the current data. Okay, lag means it will use it to access previous row data along with the current row data. It is used to get the previous value within the same table. So how will you use this syntax is there. Lag expression, comma offset, comma default value over order by columns. So select employee number, rename, job, salary, and lag salary over order by salary descending previous row. I'm mentioning for this column alias previous row from EMP. If you see, for this king there is no previous row, it is there, so that it is mentioning the null here. For the Scott, it is previous row is 5,000. Okay, so if you see this salary for this Scott is 3,000, and for his previous row is record is 5,000. Same way, Ford it is having 3,000. For his previous record is 3,000 only. Jones previous record 3,000. Blake previous record, it's Jones salary, that is 2,975. Clerk previous record is Blake. Blake salary is 2,850 here. Allen 1,600 here. Clerk salary is 2,450. Same way, Turner 1,500 is there. His previous record is 1,600. That is mentioning here. Okay. So like that for the first record, there will not be any previous record. So there it is taking null value only. Okay. So if I don't want to mention that null value, then you can use this scenario. Select a employee number, employee name, job, salary, lag, salary comma 1 comma 0. If you see this difference here, lag salary over order by salary descending, I'm taking here. Here lag offset and default values I'm mentioning. So lag expression comma offset comma default value, that is lag of salary comma 1 comma 0 over order by salary descending previous row value from EMP. Then you can check this. So wherever null is there, then it will replace with the 0 here. So when I execute this query, I'm getting in the first record null. Why? Because for this king there is no previous record, so that is null. In place of null, I don't want to show null, so that I'm using the 0 here. Otherwise, you can use any, instead of 0, you can say some 5. If we say 5, what will happen? In place of null, it is using the 5. Suppose if I want to use some name, okay, so Hari, I'll use, then it will throw the error. Why? Because offset and default values you have to give. So this default value should be number only. Okay, either 0, 1, 2, 3, 4, 5, number only. So then only it will display. Otherwise, if we give character data, so then it will throw the error. Okay, same it is. So with the use of a lag, you can get the previous record value here. So same way here lag 1 comma 0 over partition by department number, order by salary descending. So what is the difference for this and this one? So here entire table it is considered as a order by salary descending. Here order by salary but partition by department number. You see here department number 10 and 10. So in this department number 10, first record is, it doesn't have the previous record, so that it is put as a 0 here. After that, for this second record, previous record is 5,000. For this record 1,300, previous record is 2,450. Same it is applying here. Coming to this department number 20, this first record For this, there is no previous record, so that it is kept 0. And for this 3000, this is the previous record, so that it is 3000. 2970 previous record, 3000. And 1100 previous record, 2975. And 800 previous record, that is 1100. And for department number 30, this is the first record. For the first record, there is no previous record, so that it is putting 0 here. For the second record, first record value updated to 850. For the third record, second record value. Fourth record, third record value. Fifth record, fourth record value. Like that it is adding here. When use the partition by within the each department number, it is checking for the first, second, third. It is assigning the previous record here in the previous row. Same way you can use this. Select employee number, rename, job, salary, hire date, lag, hire date, comma 1, comma sys date. Okay, if you see this here, hire date, comma 1, and sys date I am giving. Okay, default value, sys date I am taking, so that for this previous record, if there is no previous record, it is taking sys date here. For this first record, there is no previous record, so that is taking 24th April 25. And remaining is same here. Okay. For this record, previous record is 3000. Hire date is 9th of December 82. For this record, previous hire date is 23 Jan 82. Same here. And for this record, 3rd December 81. Previous record is 3rd December 81. That is here. So like that, you can get the values using this analytical functions. So next we have the more example, that is last example for this session. So select employee number, rename, salary, department number, lag, salary 1, 0 over partition by department number, order by salary descending, previous row. So this is getting here. So within this department number is there is no previous record for this king, and for this 5000, so that it is 0 here. And for this 2450, previous record is 5000. For this 1300, 2450. For this department number 20, salary is here 30,000. For this, there is no previous record. For this 3000, this is the 3000. 2975, 3000 for this previous record. 1100 previous record, 2975. That is getting here. Okay. So using the lag, you can get the previous row record along with the current row value. So next we have the lead function. So this will continue tomorrow. Okay. So any doubts in this? What about the last record? So for this, you will get when you use the lag, you will get the previous record data only. Okay. So if you see this for this last record, you are getting the previous record details. Okay. But only for the first record, you will get the 0 here. 0 or null value. Okay. So first record, you will get the 0 or null value based on the lag, how we are defining this lag function. Lag expression, after that default value and offset value. Offset value and default value. This is the offset value and this is the default value. So default value 0 giving, so that previous record, if this is null, then it will applying 0. If you are not giving this default value, what it will apply? It will apply null here. Instead of the 0, null it will apply. So that I don't want to display null in this output. So I'm using 0 here. So whatever the previous record, that will be added to this current record.